All right, 5-2. We're going to take a look at arc length and area of a sector. So once again, should be a little bit of review from geometry, but we are also going to talk about how we can use the radian measure along with this. So when you talk about a circle, when we find the distance around the circle, you're referring to your circumference. So circumference is 2 pi r, or pi times d, however you choose to think about that formula. And so if I have a circle with a radius of 22, my circumference would be 2 times pi times 22, which is 44 pi. And I'm going to leave it as that as exact answer. So 44 pi inches would be our circumference. Now, let's say that you had this circle here, and I want to know, I'm going to draw my diameter in here. What would be the arc of the yellow part? Well, hopefully you're looking at it, well, that's a straight line. Right here, then, this is 180 degrees, and so that's half of our circle. So we can go ahead and just divide this by 2, and so now our arc length would be 22 pi. It's going to be half of your total circumference. Well, now what if I did this part of the circle, and now I have a 90-degree angle here? Well, if 80 degrees is half of it, 90 degrees, that's 1/4. So now I can divide 44 pi by 4 and get an arc length of 11 pi, and I should be putting my inches as well. What you're doing here is we are taking a fraction of your total circumference. Here we took 1/2 of the total circumference. Here we are taking 1/4 of it. So now, what if I wanted to go 160 degrees of my circle? More than 90, less than 180, so we know it's got to be between those two arc lengths. But how do we figure that out? You don't have to memorize a formula for this. Really, just thinking about what you are looking for. You're talking about a part of the total circumference. When we talk about a part of something, you're referring to a fraction of it, okay? We know that a full circle has 360 degrees. We are only going to look at 160 of that 360 degrees. That is our fraction that we're looking at. We're going to take a fraction of your total circumference that's here. Now, if I take 160 over 360, that is 4/9. And so you're taking 4/9 of your total circumference. So now if I take 4/9 of 44 pi, which I'm just going to type in as 44 on my calculator so I can get a simplified fraction, I get 176 over 9. And so 176/9 times pi, that right there would be your arc length right here for 160 degrees. You're taking a fraction of the total circumference. So that leads me to using this formula right here, and I was using L instead of S. Since I was using L, I'll use L. But your arc length is equal to, I have theta divided by 360 times capital C. Theta is referring to your degree. Now, there's a chance that theta could be in radians. We're going to use a different formula for this. This is when theta is in degrees. So theta equals degrees. Okay. Now, C is your circumference, and so that is just working with the 2 pi r. So taking theta divided by 360 times 2 times pi times the radius. Now, this, by all means, could be simplified, because 2 and 360 can't simplify, and we could write this as one fraction then. Theta times pi times r divided by 180. That's another way that you could think about your arc length. I just don't want you guys to necessarily memorize a formula. I'd rather you just understand that it's a fraction of your total circumference. So this, once again, is for when theta is in degrees. So you got to be careful about that. Well, what about if theta was in radian measure? Okay, so let's see, I think I got enough room here. I'm just going to kind of go underneath. I'm going to shrink this down a little bit. Just give myself a little bit more room to work with. So if it's in radians, we're still going to be working with this whole idea of what is the fraction. But you don't have, I just can't pick which color I want here. There we go, blue. 360 degrees. Now that's 360 degrees in a full circle. How many radians are in a full circle? So I'm hoping you're saying that there are 2 pi radians. So we're going to take theta divided by 2 pi. Circumference, still the same thing, 2 pi times r. Now just look at what happens here though, is your 2 pi's cancel out. And so you're left with theta times r. Well, that is your formula that can be used for when theta is in radians. How are you going to know? Looking at the symbol. If you see the little degree symbol, you know that it's in degrees. If you see nothing, then you know that it's in radian mode. Okay? So here's just an example. Let's go ahead and do one of each. Let's say that you have a degree of 170 degrees. We have a radius of 15 meters. So trying to find that arc length, we're going to take 170 divided by 360 times 2 pi r. So 2 pi times 15. Again, I'm not doing any simplifying whatsoever. I'm going to have my calculator really do all of that for me. So 170 divided by 360, well, that's 1736. Multiply that by 30, and then I end up with 85.6 times pi, and then that would be in meters. And there's your arc length. Now, if you wanted to, you could most definitely convert your degrees here into radians and do it that way. I'm just going to show you both formulas. Okay, let's take a look at another example. I'm going to go right here. Let's do a radian this time, and let's say that the radian measure is, let's go 5 pi over 4. Since I'm more than halfway, I just need to pick something that's more than pi. And let's use a radius of 8 meters. So what's beautiful, awesome about using the radian is you just have to take your 5 pi over 4 and multiply it by the radius. That's all you got to do. So when we take 5 times 8, so that gives us 40. So 40 pi over 5, and you're going to end up with, or did I do, I'm sorry, I was supposed to do 5 pi over 4. I was wondering why this was kind of goofy. My fault. 5 pi over 4. So 5 fourths times 8, which is going to give us 20, or 5 times 4 is 80. Divide that by 4, so we get 20. We're going to end up with 20 pi. And that would be then in meters. So either one is an option for you. Second part of this then is taking a look at how do you find the area of a circle. And we're going to talk about the area of a sector then. So hopefully you remember that area is pi r squared is the area for a circle. So in this circle here, I can take pi times 22 squared. And 22 squared is 484. So 484 pi inches squared would be our total area. Okay? Now, thinking about what if you wanted to find the area of half of a circle? Well, what are we going to do? divide that by 2. Take 884 pi and divide that by 2. So now you get an area which is 242 pi inches squared. We're taking half of it. What if you wanted to take only 130 degrees of that total circle? Like when you were doing arc length, we're going to take a fraction of it. So to find our area, we're going to take 130 divided by 360 degrees. We're going to take that fraction of our area of pi times 22 squared. And if I simplify 130 divided by 360, we get 1336. Okay, so 1336. We're going to multiply that by 22 pi was 484. 484. There's your area. You're going to take a fraction of it. So 1336 times 484. Not the prettiest number here, but we're going to work with exact values. 1,573 ninths times pi inches squared would be your area of that shaded area. Okay. Now if you wanted to approximate that, it would be about 549.1 inches squared if you wanted to approximate that. So when you think about the area formula, you're going to, again, area of a sector, you're going to take your theta divided by 360 degrees and then multiply it by pi r squared. Now, there's not a lot of simplifying that we can do with this formula other than maybe put it all together. If you'd rather it look as theta times pi times the radius squared divided by 360, nothing simplifies there. Just make sure that you know that theta would have to be in degree form if this is the way you choose to do it. Now, if you are working with radians, we would just take theta and divide it by 2 pi if it's radians. Multiplying that by pi times the radius squared. And some things are going to simplify here, so the pi's are going to cancel out, and so you would get theta times your radius squared divided by 2. And that would tell you your area for when theta is in radians. All right, so let's just take a look at an example real fast, one of each. Let's take a look at an angle right here of 135 degrees, and you have a radius of 19 meters. So to find my area, I'm going to take 135 degrees, divide it by 360, multiply it by pi times 19 squared. Notice I'm not using that simplified formula just because why would I do that? Why memorize something different when I know that I'm just taking a fraction of everything? So 135 divided by 360 ends up giving us 3/8. So 3/8 times 19 squared gives us 1,083 times pi then. Meters squared would be our total area. If I wanted to approximate that, which is 425.29 meters squared. And as I look at your assignments, it does have it, a lot of them have it both, approximated and exact. So either one. All right, let's do one more real quick with a radian measure, and then we can call it a day. So as far as radians, let's go ahead and say that you have 5 pi over 6. And you've got a radius of 21 meters. So here you can go ahead and take your 5 pi over 6, divide that by 2 pi, and multiply it by pi times 21 squared. Now, I will say this one would be a little bit nicer to work with your simplified formula of theta times radius squared over 2. That's, again, up to you if you want to do that. So taking 5 pi over 6 times 21 squared, divide that by 2. If you'd rather do that, that's fine too. So 5 pi divided by 6 times 21 squared. And then dividing that by 2. So my approximated version here is 577.27 meters squared. I realize that I put in pi here. If I want to find the exacts, 5/6 times 21 squared, divide that by 2, my exact value would be 735 over 4 pi meters squared. All right, so there we are, area of a sector and arc length.